And here we are back for our third and final example in section 7.5. Once again, just to review, we're here solving for the missing angle measure in a right triangle, where we know 2 of the 3 side lengths in that right triangle, and we're trying to find the measure of a particular angle. It's never going to be that right angle because that's always a 90-degree angle, and we never use that as our angle of reference. I do use it as a reference point to find my hypotenuse, though. Remember that your hypotenuse is always the side length that is opposite the right angle. In this case, I don't actually know anything about my hypotenuse, so I'm going to draw a line through that. Step 1, label each of these side lengths, right? So I start with hypotenuse. The next thing I'm going to look at is my angle of reference, which is theta. In this case, my theta is in the bottom right-hand corner, and that angle of reference is made by 2 of these side lengths. The first side length is the hypotenuse. The second side length is what we call the adjacent side. And these 2 side lengths are always the 2 that come together to make the angle of reference. In this case, my adjacent side is 13. That means that I only have one more piece of the right triangle that I need to label. The opposite side is the only side length that is not directly touching the angle of reference. So in this case, my opposite side is 9. Step 1 is to label all the parts. Step 2 is to figure out which trig function you're actually going to have to use in order to find the missing information. So you have to look and you have to ask yourself, what do I know? Based on the list that I made here in the margin, I know information about the opposite side and the adjacent side. That leads me to the trig function tangent. I have the original formula that the tangent of theta is equal to the opposite side over the adjacent side. So in this case, what I'm going to do is I'm going to replace everything that I do know. Theta is going to stay where it is and the way it is written, but the fraction on the right-hand side, instead of the letters O and A, I'm going to replace those with their values. So it's the fraction 9 over 13. At this point, I know what trig function I need to use, and I have a wonderful formula. However, I need to use inverse trig to actually solve for the measurement of this angle, because I don't want to know the ratio of the opposite side to the adjacent side. I want to know what angle is making that ratio. So I have to take the inverse tangent of both sides, because the only way to get rid of a tangent is to take the inverse tangent. And if I do it to one side of an equal sign, I have to do it to the other side of the equal sign. So now not only have I taken the inverse tangent of the tangent of theta, I've also taken the inverse tangent of the fraction 9 over 13. This is where I need to grab my calculator. On the left-hand side, the inverse tangent of tangent cancels both of those out, and you just have the theta by itself. On the right-hand side, you have what goes into the calculator. You need the whole thing, the inverse tangent of the fraction 9 over 13. So I use Desmos. You can use whatever calculator you want. You want to make sure that you're in degrees, and then you use your function menu. I have the inverse tangent of 9 over 13. When it's an angle, we round to the nearest whole degree. Those are nicer numbers, a little bit easier to work with. So 34.695 is going to round up to 35 degrees. And now we've used sine, cosine, and tangent to find the measure of a missing angle in a right triangle. I hope this is helpful in some way.